So the challenge now is I want to play with the VFD, but I need 240 volts. I only have 120 volts where I am. So what is the solution? Dig out your transformers, find one that's dual voltage, and find another one that's the same output voltage as the first one. Wire them back to back, set one up for 240. Alternatively, if you can find one that's just an isolator, you can just use that to double your voltage by putting it in series with your source. This is a hack. So, drag out even more junk heaps. When you have a little too much voltage, $75 Variac. So, that to there. $225, whoops. So we're now 220 volts. So right now, if I bring it up, $223 volts. So now we have two packages. This should be RS485 stuff. Actually, I bought a couple different options. Now this is an FTDI based RS232 converter. I bought that one because I know FTDI will work. I'm quite a fan of FTDI just because their drivers are actually good, as opposed to most of the other ones. Who's the other one? Oh God, yeah. These are actually both of them. This is memory cards and batteries for my video camera. So this is a Chinese chipset based little dongle. I suspect this has got one of those currently popular, I don't remember who made them, but it's a shitty little Chinese one with a knockoff. This is wasabi power, I guess. The power of spiciness compels you. Yep, so two batteries and a probably rather terrifying charger. Yeah, one of these. This is actually the second charger like this I've got. 4.2 volts. I'm not sure where the other one of these chargers I have is, but I've got one of these that's the next voltage up, and I wonder if I can cross swap the little. So the way these work is they have a generic charger that charges, say, 4.2 volt lithium, and then they have a bunch of little plug-ins that hold different battery sizes. And I wonder if I could swap the plug-ins across the different chargers. It would be terrible engineering if they let you do that, but it wouldn't surprise me. It would be very apropos of the Chinese. So this is much nicer than this. It's actually a cable. The converter's in here. Oops, the converter's in here somewhere. And then we have an actual breakout here, which is nice just because it this is actually 485 and 422, so you can see the different things. I think this one requires an external voltage, I'm not sure. Anyways, you know it's quality when the twist tie literally disintegrates It actually flaked off. Oh, there it goes. So this might look familiar. This is my 900 VA isolation transformer. But what it also is if you wire it right, a voltage converter. Because you can see here, we have two secondaries that are each in parallel. So I'm pretty certain that if I pull these two shunts off and put it in the middle, I'll get 240 on the output. So I'm going to do that. You can also see over here, the primary has just a complete boatload of taps, which I'm relatively confident are to allow basically voltage regulation. So you can tap where you want, and these are probably separated by a few volts. So what you can do is you can choose taps that give you your desired output voltage. So the big one, this was fun. I totally got a deal on this principally because I'm pretty sure that the guy who sold it to me paid as much or more in shipping to get it to me than I actually paid for it. I think I paid like $50 for it and $30 shipping, and it weighs maybe 20 or 30 pounds. You can see how giant it is. So yeah, I'm just gonna pull these two shunts off, and we'll take a look at what we're actually getting. So I pulled the shunts out, and you can see here that if I measure these 2 points, 114 volts, these 2 points, 114 volts, but if I measure between them, no voltage at all. Well, we have 0.2 volts, and that's just capacitive junk. So what we'll see here is if I shunt these two together, I expect to get 240 between those two. So it's all lashed up in the way I'm pretty certain it will be 240 volts. Yep, 225. Sorry, 29. My hand's in the way. So there we go. We have a converter. I got to be careful because this is, I don't want to touch that. So yeah, I now have like 800 VA at 240 volts. Actually, kind of amusing. I'm a little concerned. I think actually if I short anything out, it'll be these. I think these two flimsy little wires running to the outlets will probably wind up being improvised fuses. So this is thoroughly confusing me. This is the supposed RS485 converter, and I'm not talking to this, and I was poking around because it's not working. I've got a script running just spewing junk out the serial port right now, and if I poke this point, which is supposed to be RX plus, I get something that looks a lot like RS232. So yeah, you can see that's plus or minus about 5 volts per division. It's plus or minus about 6 or 7 volts. So I think this is a USB to RS232 converter and a random breakout. So I guess this means I'm actually going to find out if the horrible Chinese Chingus here actually works, because it looks like this doesn't. So this at least definitively has a, see if it'll focus in close. It's done it in the past. A Max 485, as well as one of these CH240, I think they are, which is a Chinese USB to serial converter. It's like an FTDI knockoff. So let's see if I can convince that to work. Oh. I found two things so far. One, the RS232 lines coming out of this VFD are horribly noisy, which is why this little cap is here. Let's see, what was the value of that part? I have the bag somewhere. Ah, well, I'll find it. And the other thing is, I don't know if I believe that pin is soldered really at all. Look at A. So I'm going to fix that. So I reflowed both of them. Actually, now the other one looks a little bit cold. It looks okay. And this is it's a 2.2 nanofarad capacitor. So let's wire it back up and see if that fixes the problem. So the converter is currently, well, it's powered over USB, and so you can see we have about 2 volts on one line and 0 volts on the other. The inverter is currently off. If we power it up, yeah, that happens. Yeah, that's a lot of noise. I'm kind of impressed. This 2.2 mic cab really didn't do squat. One thing I could do is, because this is floating completely, is I can earth one leg of the capacitor, and what that does is that basically, so it's fairly interesting. It appears that, I believe this is on the analog common mode terminal, and it should be this should be at least partially referenced to it, but I don't know why it's not. So if I earth one of these pins, you can see right now I just earthed the yellow terminal, so the yellow trace, so the purple trace is showing normally. If I earth the other one, now the purple trace is grounded and the yellow trace is driven down to negative voltage, because again, all of our measurements here are floating. But if I then go over here and say, poke the VFD, we're not seeing, it was definitely sending traffic earlier. Okay, now it's sending traffic. We can see we have, no wait, that's not traffic, that's just transitions. Look at how much noise that is. That's got to be a switching waveform coming out of the VFD somewhere. Let me put a bigger cap across it and see if that fixes anything. Kitty's coming to say hi to my scope. So what I'm actually trying now is earthing the shield, and that changes the characteristics considerably. So that's what the shield earthed, and then let's earth the scope to that as well. Oh, you don't want to come over here, Kitty. There's exposed mains floating about. Let's not have you on my bench right now. Yeah, I do not want the cat trying to walk onto that, but with the mains everywhere. So if I ground, alright, so what I just did is I just grounded the VFD to the shield of the USB to the scope grounds, and that seems to have dealt with a fair bit of the noise. So you can now see we're actually, that's traffic, but it's still not responding. But one thing I can test is if I remove the USB, the voltages decrease a little bit, but they don't change, which means I'm pretty certain I have the RS485 lines hooked up correctly. Oh, but now the now I've got the clip lead stuck in the USB connector. I just clipped it into one of the slots. Nope, and I just dropped one of the scope ropes out. I gotta put something down. Okay. So I'm now back up connected. So it's weird, this is, whatever this is, it's it's relatively low frequency. Sorry, you can see we're, what's my time doing? 100, okay, it's 100 seconds. But the 20 megahertz bandwidth isn't cutting it out at all. But if I tell it to keep polling, it should be. Oh yeah, I disconnected the USB. I gotta restart it. Actually, hang on one second. Let me tweak this off to pull continuously. Alright, I fiddled with the Spindle Talker program. Hey kitty. To pull for like forever. So what I want to do now is let's make it pulse triggered when it's low for greater than 100 microseconds. And I want to be on, I'm on channel 3, that's the correct channel. And I want to go into normal mode. Yep, hi kitty. Oops, sorry. So we're obviously ignoring all of the horrible looking data. It looks like we're poking it every 100 milliseconds. Well, it's sending it several messages 100 milliseconds apart, probably at 1 second intervals. So no, it's 500. Yeah, see, so right now we're in 1 millisecond to div, and we have bop bop bop, 1, 2. So it delays 200 or so milliseconds. I'm not sure. This is just a piece of, it's a C# app I found on the internet somewhere. But the question is, why is the spindle not responding? So there's a couple possibilities. One, the horrible Chinese converter isn't properly deasserting. Two, this is in the wrong mode. My assumption right now is it's probably 2. So let me go back into the manual. List of run commands, number 2, communication port, which is PD01. That's 2. PD02 is 2 as well. So that should be correct. So then the next thing that I need to look at is, I think, 164, which is baud rate. 163 is the address, which defaults to 0. I think I have to set that to 1. What is the address that's trying to talk to you? Yes, 1. Okay, so I want PD 163. Oops. Set. Set that to 1. PD 164 is the baud rate. So if I set that, it's currently 1, which I believe is 9600 baud. Yeah, so that is, it just went away. 1 is 9600 baud, and then the data method is 3. And that's the other problem, which is I'm not sure if this wants to ASCII or not. Probably not. So I have to set communication baud rate. It's currently set to 1. My software is also set to 9600 baud, so that's correct. I'm 8N1, which means I probably want I don't know what 8E1 is or 801, but I'm probably parity modes. So let's try setting 165 to 3. 164 is 1, 165, 3, set. Oh! Hello! Ha 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 ha. So, if we look over here, VFD settings downloaded. Shabizzle. So that was it. Uh-oh. Kitty wants to help. So if we go into settings, Kitty's trying to run the scope. Oi. Helping. Where's my squirt bottle? So, yeah, see, so now I can now read data from it if I want to. So it looks like we are good to rock and roll. So sweet. The VFD software is going, where is you? So I'm genuinely curious. I want to know what's actually in here. I want to know if my suspicion that this is an RS-232 converter only is accurate. So let's find out. Let's see. Can't decide how this was manufactured. Trying to figure out how to take it apart trivially. So the question really is I don't think the converter's in this end. I don't see the space for it. So I would assume all of the electronics are in here. This is larger than it needs to be. So what I thought was a split line is probably just the parting line for when they pot this circuit. Oh, I just tore a bunch of traces off the circuit board. But there's one of our two devices. The potting got into the legs. This is a ZT213 LEA. Oh, there went all the wires. I'd assume that's my FT232. Let's see if they lied too much. Yep, that's actually an FT232. So I now have a stub cable. That was $18 I'm probably not going to get back now. So what I want to know is, well, so yeah, so there's our FT232RL, and then this is a upside down. Oops. ZT213LEEA. Yep, so ZT213 is a RS232 transceiver. So I was right, this is in fact a misbranded case. So I'm continuing on the disassemble and clean everything. You can see I've pulled the head of the spindle even further apart. Head of the mill. I pulled a lot of the stuff off that's now down there. I'm actually going to probably replace the bearing that goes up here when I have a chance. It just was kind of old and grungy. And it's 12 bucks on McMaster, assuming I have the right one. Unfortunately, it's metric for reasons. I probably need to... I'm not sure how they happened, but it looks like there's some ding marks. There's ding marks in this shaft that I don't know exactly what created them. When I was pulling the bearing off, I was fairly careful to tap it directly vertically, so I think they predate this. Anyways, you can see I've been kind of working this. When I pulled this out, this was just full of like gooey, powdered, like belt grunge. I've scrubbed a fair bit of it out, though it's still kind of filthy. Here's the motor spindle, or the motor shaft. Yeah, so there's the that's the little drive thing that actually pulls on the actuation plate, which is that right there. And there's a bunch of assorted slip rings, or snap rings. It seems like I misplaced one. Where was that bigger? I've been just stacking them on top of that motor, and apparently I think one of them has drifted off somewhere. So what I've been trying to do is I want to pull this half of the sheave off. You can actually see there's a whole boatload of I've been filling it with WD-40 in hopes of breaking this loose, because I was pulling on this a little bit earlier with just 2 pry bars, one on each side, and it wasn't really moving. So right now I'm just going to go and try and get it free again. So I pulled a snap ring out from down in here, so I'm fairly certain that this must pull up, because why else would they have put a snap ring recessed down into this section? Well, this is simple and lightweight. I think what I'll do, this is I bought a clamping set for the mill. 45 bucks on Amazon, kind of impressive. So I'll take some time from that and unpack this. My gloves are kind of greasy, but it can't be bad for this. I mean, it's also greasy, so what the heck. So this is the air motor, and the way it works is it wraps this crank up, or wraps this chain up to pull down. So we've obviously, I think there's a worm drive gear here, and then another worm drive gear here. So this is the bottom end. Let's see if we can get this VFD to fit in. Let's see how bad my manually drilling with paper was.
Have you got the VFD working, bro?
Yeah. Well, I had it making the weird motor I pulled out of that robotic arm I took apart years ago to shake very hard and then cause the VFD to overcurrent protect. So,
But you think that the motor might have been wired wrong?
I'm pretty confident the motor was wired wrong because I just jumpered it together randomly basically.
Yeah. Nice.
Yeah, see, so just need to kind of, there we go. Those holes all line up.
Let me know if you need a hand.
Yeah, mostly just I need to.
Do you mind if I vacuum?
Not at all. In fact, I am happy that you were vacuuming. Because that means that.
Like a prodding, scraping tool. The brushes.
You can use that X-Acto knife. It's right next to the speed change thing. That's more or less what I've been using for a prodding scraping tool. So now the question is, can I get these holes to... Can I get these screws to start? And the answer apparently being no. I just have to get these little wire loops out because I put these in so I could clip lead onto them when I was testing it on the bench.
Cool, I mean, it's totally, yeah. Looks like it belongs there almost.
Yeah. It does kind of poke out a little further than I think it really should, but that's such a minor issue, I'm just going to deal with it.
Yeah.
So I may re-strip the ends of these wires because they're don't look too great. I love these wire nuts.
What do you figure this? It looks like there's a tray around the bottom of the motor.
That's a fan duct.
Oh, it pulls the air in from above?
I think it actually pulls the, yeah, I think so. And then it blows it back up the outside because you can actually see there's like fins.
Yeah, right.
So I'm pretty certain that's part of the ducting.
Okay.
I suspect this is one of those TEFC, totally enclosed fan-cooled motors. So the way the cooling for the motor works is it cools through the fins in the housing.
Yeah, right.
Don't quote me on that.
And the air just comes out of the top?
It actually comes out of the vent grill in the front. If you look at the top half of the speed adjuster, it's got like a grating on it.
Cool.
think.
Oh yeah. Okay.
I'm kind of guessing a little bit.
No, I think I see what you're referring to. Wait, where are the hoses for the speed adjuster?
They're just hanging.
Oh, I see them.
Yeah.
Oh, lights.
Yeah. So now I have to just get these two seated in. Make sure I'm not sticking my head in the way of the camera. Once it's in the slide, it's fine. Tuck it like that. Let's go get my nut grabber. That works. That would be an OCD. I'm ruining everything.
Well, you know if you need a
I think I need a new brain, please.
fresh out.
Everywhere I looked, it's been out. It's really not. Yeah, Frankenstein RS.
WD-40 cleans pretty good. It smells fantastic.
Yeah, my concern is you really want to keep, I guess it's probably not really a big deal, you really need to keep the lubrication off the surfaces of the sheaves.
Right. That makes sense.
So I think we can always just scrub them down with solvent later on.
Yeah. I mean, I'm basically not touching them at all.
Yeah. It's worrying about it now is probably stupid.
Actually, the ones that are on the table are in more danger just from dripping.
Yeah. Okay. Doing these. Ooh, just long enough.
The wires.
Yeah.
Sweet. Yeah, I mean, you got most of the crap out.
Yeah.
It would be cool to like disassemble the whole thing and clean it a little bit more thoroughly.
Yeah, it's just,
Fuck it.
yeah, that's kind of the approach I'm reaching. I'm pretty much at the, fuck this, we'll just put
I
the,
mean, there's really nothing wrong with like.
yeah, it gets dirty when it's used.
Yeah. Yeah, I mean, even if we cleaned it out spick and span, it was kind of like.
Yeah, you look in it a month and it's all bleh again.
Yeah, I wonder how many years this machine was in service.
Not that many. It's in too good shape to
I
have
mean,
been.
yeah, you're right. The ways like aren't worn in at all.
Yeah, you ever like look at the ways in like the student machine shop or anything like that?
They're like gone. They're like, I mean, they're fine, but they're well worn.
Yeah, they have like no the scraping marks left, right?
Pretty much. You can still find it on like, especially on the Z-axis.
Yeah, well.
Those aren't moved very.
Yeah, because it takes work.
Right. Yeah, those don't go back and forth all day. I'm afraid beyond cleaning, there's not a whole lot.
Yeah, well, momentarily I'm gonna power this fucker up and we'll.
Yeah, I'm just gonna watch you for a while.
That's fine. Yeah, so the only thing I want to do right now is, can you, I lost some bolts down there.
You want me to fish around?
No, they're just on the floor over here. I just don't want to get up. I'm just that lazy.
Where?
They're right there. See the long socket cap things? Yeah, there's 3 more up here. Those are what hold the lid on. The other 3 are right here. The just put them with the rest of them.
Okay.
I just want to keep track of them because they're kind of important.
Yeah.
Check out these wire nuts. Aren't they awesome? Look, they've got rubber cowlings on them.
Pretty fancy wire nuts.
Yeah, I bought a big box of them.
Is it like a strand leaf thing?
Yeah. Well, and just keeping them more sealed thing, I think.
Why do you need to seal them?
Well, there are actually wire nuts that are full of grease. Because then if you use them outside, they're fine. Like,
Weird.
yeah, they're full of dielectric grease. It's really cool, actually. Yeah, or something like that. You know, and then the idea is you use them outside, and the wires don't oxidize and get all grungy inside of them, despite the fact that they can be like moist.
Can I move the
Yes, absolutely. You can do pretty much whatever the fuck you want. Just
don't break shit.
yeah. The only thing that's really kind of obnoxious to move at this point is the 3D printer,
Yeah. Well, I don't mind.
and that can just live on the table.
Yeah. Right.
I'm probably gonna put that other big 20-gallon tote in the back shed in the near future.
Oh, this one right here?
Yeah.
Cool. Yeah, I'm just gonna tidy up a bit.
Yeah, do whatever you want to do. You're probably doing stuff that I should have done and was just lazy.
Well, you're getting the power up, so I think that takes priority.
Yeah, but I also live here.
Oh, what's this like contraption on the floor here?
Which one?
This thing?
Which thing? That's the cash half of the ATM.
Oh. Ah.
It didn't have any cash in it. I was very sad.
Yeah, that's kind of sad.
I still haven't had the balls to post that video on YouTube.
What, the breaking into the
Yeah.
Why?
Because we found it on the side of the road. I don't know if it's not hot.
I did not remember that detail.
Yeah.
That's hilarious.
I found an ATM and brought it home and took it apart. That's
I swear, I found it on the side of the road.
yeah, I mean that's like the quintessential lying through your ass story.
Found it.
And that's literally what happened.
Hilarious. What are these?
What?
It's a little baggie of like, here, I'll show you.
Those are saw blades that go on a vibrating multi-tool thing.
Oh, okay. Oh, I think I. No?
Yeah, they're ribbed for the wood's pleasure.
Ew.
I like how you laugh and then go ew.
Because it's funny and gross.
Just your order of operations has me kind of bemused.
Whoa.
This is the first time the VFD will actually be grounded.
Yay.
Safety. Third.
See, what a good idea.
Safety. Yeah, we'll get to it eventually. Oops.
Safety. I hear that chafes.
I'm so happy that's catching on.
What?
I hear that
I
shit.
hear that chafes. Yeah.
Like, see, I have had a positive impact in the world.
Yes. Yes, you contributed to the English colloquial. What do you call it?
Colloquial vulgarities.
The idiom. Or something.
The cultural gestalt of horribility.
Yes. The zeitgeist.
Yes. The chafing zeitgeist.
The chafing zeitgeist.
The chafgeist.
Is that like a poltergeist with chafing?
Yeah, it's like that's when you get a poltergeist in your jockstrap.
Yeah, right. God, that poltergeist chafes. We need more hooks for hanging wires.
Yeah, I know, right? If I'm down in Ventura tomorrow, I'm not sure if I'm going to go down to visit my parents. I'll go to Horrible Freight and buy some more.
Oh, cool. Perfecto.
Or realistically, I'll just buy them on Amazon because that's where everything comes from these days.
Yeah. Apparently Amazon.
Have you been completely ruined by Amazon Prime? I have.
If like basically only ever buying things online from Amazon and using Prime means I'm ruined, then yes.
Well, yeah, but like buying stupid shit that you could just go to this 99-cent store.
I haven't done too much of that.
I bought toilet paper on Amazon Prime.
Alright, you were more ruined than I.
Yeah, well, I blame John for that.
Yeah, I remember. You were talking about. Was it his idea?
Well, he's the one who told me you could do it. And then I tried it, and now it's like, fuck.
Never need to go to the drugstore again.
No, I don't buy it there anymore, but can you put that in? It's just in the bin over there. I don't do it anymore because it turns out that it's way more expensive than just going to Costco.
That's hilarious.
Yeah, right?
No, this is great. It's gonna be a cool little workspace.
Yeah.
Oh, is this what? Yeah, is this the one you were talking about?
Huh? Yeah.
Holding the chain on. I can toss it, right?
Yeah. I have a whole box of them from Horrible Freight.
Yes. And these little scraps of wire, you don't care about them either.
No. Well,
Just toss
if they're more than 6 inches long, save them. Yeah, that's totally recyclable. Hell, I've made like some of these jumpers in here out of sections of wire that were removed.
Where did this come from again?
That goes on this motor, and we should put it back, but it was held on by one screw.
Well, it's
just
going to be held on by 2 screws eventually.
I don't know, because I can't find the other screw hole. Seems to be gone.
The screw hole's gone?
Yeah, there's just a hole there.
Oh yeah, no, that's right.
Yeah, we weren't totally sure what they did, but they made a mess of it.
They fucked it up.
Yeah. Yeah, it was kind of one of those, what the hell happened here?
Yeah.
Like, it almost looks like there's like there was supposed to be like a casting flange in there and they broke it off or something.
A what flange?
Like a little flange or something on the casting. And it was like cracked off or something. What I'm saying is I think they did crack.
They broke it. They done broke it.
Okay. So the 24-volt supply won't come up, which means the servos won't come up, but we should be able to power up the VFD.
Well, what do you mean it won't come up?
Because the power leads are right here.
Are those the live ones?
No, this is the 24 volts. The mains goes in here. I knew where the mains goes.
Oh, that's 24 out, yeah.
The 24 volt out is 105 and 106, and I don't remember which one of these the earth has to be ganged onto, so I'm just leaving them floating until I can dig around in my files and find the documentation on it. So what I'll do right now. Oh, I bought a cover plate for the outlet. So it's not just like open anymore.
Sweet.
Yeah, I bought 2 cover plates actually. I bought the wrong one the first time.
Oh, it looks pretty.
Yeah. It's not supposed to be blue.
Yeah, oh, it's got the...
Yeah,
there you
and
go.
I put the screws in before removing it.
Oh, that comes right up.
Yeah. So we did 2 stages to power this up. First, that goes in, and then we come over here, and then we go like this. And then we wait a couple seconds.
What's the couple of seconds about?
The VFD waking up. And then we go, why is it? Oh. 3 stages. Turn on the breaker. I don't remember what that noise is from. It takes like 3 seconds to boot. I don't know why.
It's so funny.
Yeah. So. VFD. So I got a
Ouch. Ouchie poo.
I just found 240 volts.
Ouchie poo.
So that has to be set to 1. And that has to be set to 1 as well. Because it was set to be run by the
Are
external.
you okay?
Yeah, I'm fine.
Maybe we should put a little cover on those. On those legs.
That doesn't quite work.
Oh my god.
It's fine, just don't do that.
Just try to avoid.
Yeah. So
Well, are we going to be
No,
in here messing with it?
no. Hopefully not.
Okay.
So it should be in
Occasionally.
manual mode right now. So let's go back to 1 program. Set. It should be set to 1. PD2 should also be set to 1. I don't know why it's not responding to run commands. Let's restart it. I don't necessarily know if some of these commands require rebooting. Don't you love how long it takes to come down after?
Is that just caps? Or like,
It's got 2 huge capacitors in it.
that's impressive.
It's got like 12,000 microfarads at 400 volts.
Jesus.
Yeah, so now
So that's why it takes so long to come up.
no, the caps come up immediately. It just
Really?
takes it. I don't know what's going
You
on.
think those caps charge right away?
Oh yeah. So that's 1 and that's 1.
Isn't that like a lot of current or something?
Yeah. It's gonna have huge burst current.
Well, yeah, I guess that's true.
So where's my okay, well it was working the other day. I'll have to fiddle with it more.
Okay.
What the hell? Yeah, I had it where I'd push the button and it would work. Let me go get the manual.
Yeah, no worries. I mean, it's just, yeah, fiddling.
I want to see the motor go around though.
So it's 240 in and then 3-phase out.
240. Yeah, it's got 3 half bridges in it that run the outputs. It's a very simple system from a functional standpoint.
The VFD is?
Yeah. It's just making it work properly is hard. And the volumes are small, so they're expensive.
That's a good idea.
Yeah, I'm fortunate it only bit me across 1. It only bit me with the capacitance to earth through my body. And it was surprising.
Yeah.
So,
Is that the one that got
no,
you?
I got that. It was
Yeah,
that one, but that problem is that one's even shorter.
Yeah.
I don't know if this plan will even work for that one. So that's how a line it works.
Yeah. Tapered. Like massively tapered thread.
Yeah, and it's a spring thread too. It's like a reel of spring steel. Let's see. 17, 18, set. I mean, it wasn't 18. Set. I thought 18 was the hang on 1 second, let me go actually get the documentation.
Yeah.
Oh, that switch!
You like it?
I love that switch! how about I actually put it, take the blade out before you stuff it in the bag, please?
The saw blade?
Yeah. Oh, and the other thing of note here is, did you just fart?
A little bit ago. Yeah, that makes sense. I was just kind of placing it in the bag region.
Will you stop fumigating my shed, please?
Yeah. I thought you were going to be gone longer.
I was just going to get a book!
What's... Oh, this is an air... This is an air hose? That's crazy.
What? That giant blue thing? Yeah. Yeah, I need to reel that up and hang it somewhere.
Well, I'll do the reeling up part. I'll stuff it somewhere.
Let's see, it's PD13, that's the parameter reset. Oh!
Shit. It's spinning up?
Yeah. I told you this thing ramps the speed up.
Oh, that's right.
Oh, I just reversed it. Yeah, look, that's the RPM readout. Watch, it'll go backwards.
There's an RPM readout?
Yeah. Well, so you tell the VFD how many poles the motor has, and it can then infer the speed of the motor from the frequency you pass it.
That's so nice.
Yeah, dude, this thing is awesome. See, yeah, it's supposed to be going 1440.
That's,
and then
it's 1440 given the...
Yeah, well, it's running at 50 hertz right now.
Oh my god, that's amazing.
Hey, check it out. I can turn it down.
It's a nice little box. You turning down the frequency right now?
Yeah, it's currently 10 hertz.
You don't work too good at 10 hertz.
No, it works fine at 10 hertz.
That's bitchin', dude.
Yeah, look, let's take it down to 5.
Man, that shaft is a little wobbly, isn't it?
Look, it runs at 1 hertz.
Oh my god. Well, why wouldn't it run? It's just starting. Sweet. I love the noises.
Yeah, right?
It's funny that the noises are coming from the motor.
Why? There's literally nothing that can move in here.
I guess that's true. I mean, it's the windings all in the motor making that noise?
Yeah, it's magnetostriction, man.
That's crazy.
Yeah,
so the fields are like basically smoothed out by the coils, but the coils themselves feel the pulses.
Yeah.
That's crazy. That's so weird to me.
So it's an inductor, so you're driving current into it. You're letting the field build up and decay at a fixed rate.
Mm-hmm.
All right, there we are. PD5 is max operating frequency. That needs to be 60 hertz. Set. Min frequency, 0.5 hertz.
Are these just parameters that you're putting in?
Yeah. It's taking 2.5 amps.
Like, are they presets or are you punching in parameters?
I'm punching in parameters. Program. So PD5 set. Why doesn't that stick at 60? Set. Yeah, and like other things we can do is you can connect a giant power resistor to this, and it will you can just shove it back by the weed whacker, and it'll use the power resistor to make it stop hard. Because the problem right now is it's hard on it to stop the motor because it's got to dump all that energy somewhere. So you get like a 100 ohm 300 watt resistor and you just clamp it to the side of the box and it'll dump all the power while it'll stop the motor.
So it's basically discharging the field of the motor. Yeah.
Because the way these things work is there's basically a rotating magnetic field in there.
Right.
And then what happens is the secondary, which is the rotor, is shorted basically. So it's resistant to, it doesn't want to move. So as long as the field rotates, the rotor tries to follow it. And there's a certain amount of what they call slip. It doesn't quite keep up, and that's the rotor slip. And this thing can actually correct for that. Yeah, like you can.
What do you mean correct?
Like you tell it what your expected slip is at your load, and it will automatically compensate if you tell it to go to an RPM.
What do you mean compensate?
Like output a higher frequency than you necessarily need to counteract the fact that you expect a 2%. Slip.
Well, so the slip affects your RPM. I guess I don't really understand.
So what happens is you have a rotating field, and you have a rotor that's got a shunt winding in it, so that the rotor.
Your rotating field is just three different coils, right?
Yeah,
so
but if you look at it from the standpoint of something in there, it looks like you have a fixed field that spins.
Right. But it's three fixed positions.
Well, no, because they're sine waves. They're sinusoidal, so your vectors all add. So it looks like it's rotating and continuous.
So right, okay. So
you have a field in there that looks from the perspective of the rotor like it's rotating, and because your rotor has it's shorted, any current that is induced in that induces a opposing magnetic field, which produces force on the rotor. So that's why the rotor moves.
Yeah, right.
So the issue there is that the rotor isn't locked perfectly to the field because there's losses in the system. So what happens is the rotor spins slightly slower than your field does.
Slower.
Yeah, because it can't quite keep up. Because there's a little bit of resistive loss in the shunt winding in the rotor and a lot of other things. So what happens is
that's weird actually.
Like if you have, how a lot of motors are rated 1750 RPM. Well, theoretically from 60 hertz they should be running 1800. Okay. But under the specified load they lag 50 RPM every 1800 RPM. Lag 50 revolutions every 1800 revolutions. So. Because if you think of it, there's no, you have to have some motion in order to generate the counteracting force. So it has to always be falling behind slightly in order to generate the field.
Yeah, right.
Because if it was perfect, there would be no reactive field coming from the rotor. So what you can do somewhere in here is the, I saw the parameter at one point, but there's a parameter in here. That basically lets you set what kind of I don't remember what it was. I saw it somewhere, but it allows you to compensate for that.
Yeah, that's kind of cool.
Yeah. So here, let me take it to there we go. That's normal operating RPM. That looks pretty smooth to me.
Yeah, it looks pretty smooth. It spins.
Shaft around. I kind of want to put the sheaves on so we can actually make the spindle go round. You want to put the head back together?
Yeah.
Oh, well, we can't. We're missing the bearing.
Yeah. You tossed it?
No, I have it.
It's kind of thrashed, yeah.
I don't know if I really want to. We can put.
This is definitely wobbling.
Yeah, but not enough to be a problem.
No, I don't think so. Oh, wait, no, that's not wobbling, it's heat.
Oh.
I'm like, why is it rough?
Yeah, I definitely want to.
Keyway.
Oh, that's what that other noise is. It's the monitor freaking the fuck out. I'm like, what's that other squealing noise? Yeah, we could put that half of it together, no problem though. Think this tripod's tall enough?
I just don't understand what could have possibly caused this
What?
weird thing in the key.
Well, so you have to realize that a lot of your torque is transmitted through that key, and because of the way the system's designed, the sheave has to be able to move.
What do you mean the sheave has to be?
Well, that sheave, the lower sheave there, is the half that slides up and down.
It goes up and down, right.
So it's possible if you have an interrupted cut, it relaxes, the motor accelerates, it slams to one side. You hit that the tool hits the part, it slams to the other side. So my assumption here is that what you have is you have basically a very violently modulated load.
I just don't buy that.
And what would happen is it would just take your pulley and it would just go.
Yeah, but that just seems wrong.
Yeah, I'm not sure.
I mean, is this a broken part? Is this like not gonna work?
No, I don't see why not. I mean, it's not like the pulley can spin. It just has more play than it probably should. It might be a problem in a couple of years, but I don't think we're going to use it hard enough for it to be a problem.
Yeah, no, I get you. I don't know, it doesn't make sense.
Yeah.
Oh, there's a weird little
What?
film in there.
It's probably just grease peeling off.
It is?
Oh, that's probably a shim.
Oh, yeah.
Because it's got to be a very snug fit, and that's also a bearing surface.
So here's what I'm noticing about this. That's not a key.
Oh my god, it was a key once.
No way.
Yeah.
Oh, no fucking what? That's outrageous. That is out of control.
It was a key at one point.
Look, it's like broken all the way back to
It's not broken, it's worn.
It's worn, yeah. I mean, it's like gone.
Yeah, maybe we'll have to take the motor out and have somebody re-weld the shaft. Probably.
Fuck, dude.
I'm just gonna run it the way it is.
Well, okay.
Let's run it until the pulley breaks fully, and then we'll worry about it.
Why? Yeah.
Yeah, it was a key at one point. Yeah, so the way this works, you want to drag the chair over here if you want to take a look?
Yeah, sure.
Yeah, that's pretty fretted. So you're gonna have
No, that's sweet though. So theoretically, we're good to go on the power.
Yeah, I mean, there's a little more fiddling that needs to be done.
Yeah, some straightening out, but it seems. Oh, am I gonna be in the?
You don't know where. You can just move it. Hang on. Yeah, let's put it over here. Ugh. The joys of being an internet video star. Yeah, let's move. You're into there. Yeah, I went to the local hackers race and some dude was like, "Don't you have a YouTube channel?" And I'm like, yeah.
Okay, so like, look at this guy on this
Yeah.
side. It's a key. It's like steel, right?
Yeah.
It's steel all the way down to the inside. The
Yeah, I don't know.
the ID keyway, right?
My assumption would be that some of this is probably designed with the assumption that that's going to be the wear part. Yeah, anyways.
Like that's what's really baffling me about this.
Which is why did it just
is the design?
ruin the shaft?
Like that just doesn't seem right at all.
Yeah, and to fix that, we'd have to take the whole head off, which is.
Yeah. I mean, that's a big
I'll
fix.
have to buy that gear puller I was looking on Amazon. So see, that spring goes like that. This pulley is down, and then what needs to happen is this snap ring. This is I think this is just a precautionary thing. Now I have to get my gloves unstuck. Yeah. See, that's I don't think that snap ring is. Oops. Yeah, that keeps happening. I'm pretty sure it's just there because it's intended to prevent the. This is like an assembly aid snap ring. The result being that it's kind of useless. And that keeps happening. This is kind of opened up a little more than it should have too. I wonder, this might have actually been a real snap ring at some point. This might have also fretted. Though realistically, this gap is largely a function of the belt. It's never really forced like that by the. This sheave should never come up far enough that it hits this under normal operation.
Right.
Which is why I think this is just like an assembly thing. Why I think the snap ring is so flimsy and shitty. Now the problem is, am I going to get it stuck in this top groove? Guess not. There we go. Safe. So then the next thing that goes on is that half. And this one's kind of greasy as well. And then the last one, we just have this small outer snap ring here. Where my snapper pliers go? Oh, yeah, they got the red handles. That is the wrong one. What? Okay, I'm missing another snap ring. Should be one more. Under.
I'm not seeing it.
Joy.
Choice. Why do you think it's not those little bit?
This one's too big. See,
What about this one?
That's an inner snap ring.
I see. Right.
I don't actually remember. Oh, you're right, it is this one. This is just a really funky looking outer snap ring. I'm like, why is the wear pattern on the inside of this outer snap ring? I think this was assembled wrong. Because this is...
Yeah, that's
an inner snap ring, but look, it's got wear on the inside. I think there was a monkey in this thing.
Yeah, I'm getting the feeling that there was some funny business here.
Well, as long as all they did was make a mess of the spindle, I'm okay with it.
Yeah, we can get the spindle back into shape.
Yeah. Yeah, so probably that one I think I need to
Watch the lane. Or nothing is.
Can you I wish we had another step ladder. Yeah, actually
I could stand on the table, but I
don't want you to do that. But what I have done is I have stood on this box. So in a second.
Oh goodness.
Yeah. So
You sure that's a good idea?
yeah. So what I want you to do is, while I push the lower half of the sheave down, I want you to push the top half of it down and then try and seat the snap ring. The snap ring should seat now.
Should I just tap it in with
Yeah.
this or something? Yeah. Oh, sorry.
Is it going in?
Going down a little bit.
There it is. So you just want to make sure it's snapped all the way around the circle. Hang on, let me.
I'm not sure it is.
Yeah, it looks like this section here is only the ends popped in.
Yeah.
So
Maybe that's part of our problem.
yeah, well, you tap downwards on the pulley. Yeah, so now make it top.
Very awkward tool for this.
You want to grab a better tool? Oops.
Is it still not in?
I can't decide. It's good enough. Yeah, wow. Yeah, see?
Yeah, that's crazy.
Yeah, that's gotta be a problem. Hopefully not in the near future. We'll just rock with it for the moment.
Well, it seems like it's, yeah.
It'll break eventually, and
It's only a problem when the tool's actually engaging the metal.
And has an interrupted cut.
Yeah, right.
When your torque loading is not constant, I think is when this is really going to be a real problem.
Well, that's bad.
Yeah. But I figure let's let it fail all the way, because I bet it'll work for a few months.
What if we replace the key?
It wouldn't really help because the problem is the keyway is so fucked.
Yeah, but there's even just a lip on the keyway would help, right?
Yeah, but I think what's going to have to happen is the shaft is going to have to come out of the motor, and the shaft is going to have to be well built. I know at least one dude on YouTube who does stuff like this, and I bet he charges like $300, $400 for it. You know, which is not terrible.
No, I mean,
it's mostly just
better than buying a replacement motor.
Yeah, it's mostly just it's going to be a lot of work to get that out, and I want to just make it work now. What I'm curious about is why is so much of the torque being absorbed by the bottom half? Why is the top half all fucked? You know, why is the bottom half shredded to destruction while the top half? Well, I bet the top half's a snugger fit. It's certainly pretty concentric. Well, the bottom one wobbles around a little bit until the belt centers it. But,
well, yeah, the bottom one's the
mobile
screwy one.
Well, no, but the bottom one, its concentricity shouldn't really be affected. I think the problem is that it's just tilted a little bit. Its concentricity should be
that's why the shim is in there, right? To try to help.
Well, that shim is just in there so that when the belt's not in there, this doesn't fire off the top.
No, the shim, like on the inside of.
Oh yeah, okay. So maybe this has had a lot of problems. Maybe we'll have to weld build the whole shaft and then have it turned in diameter. Yeah.
I see.
Something to worry about.
Yeah. Well, it's something to look into. Interesting.
Yeah.
Sounds like it's not a showstopper.
Well, it's a near-term major problem. I'm just caught up on the fact they put an inner snap ring and an outer.
It doesn't quite do what it's supposed to.
It works badly. I kind of want it powered up now.
Just to spin it with a little bit left?
Yeah. Well, I just because my expectation is that.
Do you want to put the
no.
belt on? Oh well, because
we need to pull it. Because the top half has to all be on.
Half has to be there. Yeah.
We could put the sheave on and just make sure it slides smoothly. One hand with the other half of the sheave.
You mean just to see if it?
Yeah, to see if we've successfully deburred it sufficiently.
Yeah.
I'm still probably gonna polish it with some sandpaper.
Oh!
Yeah, okay, wow, that's so much better.
Okay.
I had to go hammer it over when I took it apart.
Yeah, I bet it's because those burrs were there already.
Yeah. But see that's sexy.
Yeah.
And look at how there's
right.
very little radial play. I bet the problem is that there was just too much.
There was play and then the problem
It just snowballed.
Yeah. That's incredible.
Yeah. And it probably made chunk noises.
Oh yeah. Yeah.
I bet the whole drivetrain sounds terrible when you're making an interrupted cut.
Yeah. Well, we'll find out.
Yeah. So the next thing we could do
do you think that might have contributed to that bearing failing?
The bearing hadn't failed. I just replaced it because it was there.
Oh, okay.
I only replaced the bearing because it was available and easy to do.
Okay.
I
seem to remember you saying that the bearing was stiff or something.
It was gross,
Yeah.
and it didn't spin freely, but that could just be because the grease in it's old. It probably needed to be re-greased at minimum. Let's kind of put this most of the way together. So these screws. This.
You hit?
I just need to locate the screw holes that there.
Yeah, this is the vent that you were talking about?
Yeah. I think that's where the air comes out or goes in. I'm not too sure which way it
That
goes.
makes sense.
So I'll take my terrifying sounding screwdriver. Oh, I found these at Osh. It's a $24.99 electric screwdriver.
Nice.
Yeah, so I should have asked you to clean this while you're at it. Oh, here's another terrifying cotter pin. Oops, and then that happened.
Oh, that thing. I mean, that just needs a little WD-40 and a wipe down. Well, some Scotch-Brite might help.
Yeah, see, all the surface rust on this is kind of why I think it's a little wet. That goes like that.
Yeah.
And then this goes through the front and the chain hooks onto it.
Yeah.
The problem
we
is,
don't have to put this part together.
yeah, the problem is I'm not sure which way the chain is supposed to wind around it.
Right, yeah.
Because, well, I can spin the air motor using the compressor. Which is nice. So I can make sure, you know, and then when this is torqued down, you're at the lowest speed. So therefore,
Right,
well,
yeah.
no, when this is all the way pulled down, you're at the low speed. So currently it's at 4,200, 500, so it should be at the highest speed right now, which means that the chain should be unwrapped. Yeah, yeah. So it should be like that, because this sheave is going to basically be up like that.
At the top, yeah.
Because there's a,
All the way on the inside.
yeah, while I'm thinking about it, it's a little bit stiff. Wow, that's so much easier now. While I'm thinking about it, this, remember how I said, my snapper pliers go here. So this is the, this is the ring that came out from down in here. So.
Oh, right. It's the ring.
And this is why I was fairly confident that this.
Unnecessary ring.
Well,
Right.
unnecessary after now that it's been cold welded in place.
Yeah. Yeah, I definitely get the impression that some hack was in here before.
Yeah, I
hack,
think.
some hack who's not us.
Yeah, well, there's hacking and then there's
Right.
expediency. I'm hitting it with a file. I think we're hacks. You have a point. Yeah, but so why would they put a snap ring in there if this section didn't come up?
Well, I think it's got to come up because this doesn't
And how
seem
else
to be
would the thing
any
come
other
apart?
way. Yeah.
Yeah, so my assumption here, and then this other snap ring here sets the upper limit of the sheath. It just goes like that. And then the bearing goes on this section here.
It's kind of a weird spot for a snap ring, though.
Well, where else would you put it?
I mean, well, I guess it's just the diameter change in the
Yeah.
in the shaft. That's kind of weird.
Yeah, I'm not too sure why there's a step there either.
Yeah.
Yeah. Where's the keyway?
Yeah. This is a little bit of a disaster, but
It's a near-term concern. There we go. Yeah, so then we're gonna have to take that off to put the belt on it. Yeah, see, it's pretty smooth. It's just the last little bit. I'd rather it be overly snug than overly loose.
Oh yeah.
You know, and besides, the total, it travels from here to here. That's its total movement. Because this snap ring here goes in this slot here, and then the bearing sits on top here and it fits in there. But I'm not going to put any of this on because to get the belt on, we have to have the top half of the sheave off because we can't fit the belt around everything the way it is right now. So the order of assembly is belt, top half of sheave.
So we could just leave this assembly for now.
Yeah, that's how it, yeah. You know. Yeah, don't stop making it worse.
Just freaks me out. I think we should try to replace that key.
I'm down for that.
I mean, the fact that there's plastic and then this really worn out key, it's just so fishy to me.
Yeah, my concern is the key will just get munged up in a very short period of time.
Yeah, it could be.
Yeah.
I almost feel like maybe there was a key failure first.
Well, but the key didn't fail. The key's still solid. It's just half worn.
The key's mostly gone. Yeah.
But it didn't crack.
No, that's true.
Yeah.
Well, maybe it did crack and then failed from there. I don't know. Anyway.
Yeah, isn't this
Funky.
it's the string in there that you used to split it.
Yeah.
Yeah. What we should do then is we should go. I should go get my calipers so we can measure that and we can order some key stock.
Cool.
They're on my desk inside.
Do you have a grinder, by the way?
I have that.
Grinder?
See the sand thing down there?
Oh yeah.
It's a disc and belt sander, so kind of.
Yeah.
So.
It's kind of like a grinder.
Yeah, it removes metal
Yeah.
in an expedient manner.
It'll work.
What for?
What's that?
What do you want to grind for?
Oh well, just to get the key sized and.
Oh, okay. Yeah, I haven't done any of that. Let's wobbles a little bit.
Yeah, it's a little ugly. And then we just feel it. Definitely on the weapon side.
I think that'll be a lot better once the belt's in there.
There's the belts, yeah, it's stabilizing it. Well, it's just that the bottom plate is very cockeyed.
Well, yeah, but a lot of that. Well, actually,
But that shouldn't really throw off the balance, should it?
yeah, I'm not too sure why that can be cockeyed because it should be a. Let me get back up there and take the top half off. How does that have sideways play?
Yeah, that's what I'm saying. I think.
Okay, yeah, I'm now realizing why can that have play? It should only.
I'm feeling like there's something very funky going on with that.
Yeah, why does that have play? That shouldn't have any play in that axis.
I think this is part of the issue.
Yeah.
There's
You're
just
completely right, which is
good catch.
completely unintentional.
Maybe we should buy another outer snap ring.
I always like to fire off in random directions.
Yeah, right.
After I just do that. Yeah. It auto ejected. Yeah, it's too bad we don't have a lathe. I wonder if we could bug the hole.
What do you want to do with the lathe?
Oh my god!
What?
That hole ain't round.
No, it's not. That's what I'm saying. This is a fucked up part. This is a very fucked up part. Maybe we need a replacement.
Yeah. Well, the good news is I think a lot of this sort of stuff is common.
Yeah.
You know, because the shaft is. Can you go hit the go button on the? Oh, turn the power on and hit the go button on the VFD.
So the switch on
the big
side.
giant clunkiness, and then the.
This.
Yeah. You have to wait a couple seconds, and then the VFD will come up.
And just hit run.
Just hit, yeah. You gotta push it kind of hard. What is thumping in the motor? Okay, that's gone. Yeah, the shaft doesn't appear to have worn while this was like that. So the shaft, I'm looking at everything but the Eaton keyway, and it seems to be all concentric.
Yeah.
So my point is that my concern was whatever mechanical action ate this section out of this. What is? It wants to grab. It likes me. So why was this going? Thunk, 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 while it was spinning out?
The spring.
The spindle. It's all. Everything's off. It's just the bare shaft. Yeah. Start up. Start up again. Hear that thunking?
Doesn't really. I mean, it could be a bearing.
Yeah, it could be. Yeah, okay, so it definitely pulls air down and then blows it up.
Oh, cool. Can I take a look while you turn it on?
Yeah, sure.
Let me hear this.
Yeah, that should not be making knocking noises.
I mean,
It's probably a bad bearing.
Yeah, it could be the bearing.
But it doesn't, I don't feel like a lot of play in it.
No, it doesn't. It doesn't make the noise when it's. It doesn't make the sound when it's not powered.
Yeah, but it doesn't matter. It shouldn't be going thunk.
No, but I mean, wouldn't it go thunk right now? Right?
And it kind of goes away once it's up to speed.
Yeah.
But you can still feel a little bit through the chassis. Yeah, the shaft seems great.
I mean, it seems to be running true.
Yeah, that's my point.
Pretty long shaft. Fire it up.
We can also turn up and down the speed at which this thing spins up and slows down.
Oh,
it's
cool.
in like the 10-second start up and turn off.
It's reasonable.
Yeah.
Yeah, I don't know. It's very odd. That's all I can say. It's just weird.
Yeah.
It's just so weird that.
Yeah. Well, let me. One of the things I'd actually say that would be a good idea is.
Do you? I wanted to take this out.
The set screw?
Yeah.
Yeah.
So maybe we can pop the.
Yeah. Well, or drive the set screw in and see if that drives the keyway out. Let's do that. One of the things is and kind of one of the reasons I'm gung ho on the whole YouTube thing is very hive-mindy. People who watch my channel actually know how to machine. So I post a video about this and they'll just go, "Oh yeah, that's problem X," and I kind of go, "No."
Look, the outside of this has some weird wear patterns. I don't know if that's.
That's just the spring fretting on it.
Spring, right?
Yeah.
Okay.
So the problem here is just. Hole is not round. It's very out of round. It's clear on this end. It's way thinner here. And the key has been chewed up. So let's see if we can't convince the key to come out. Yeah, I've kind of given up on keeping the table totally immaculate. I'm just using it as a workbench at this point.
I mean, yeah. Well, I think we should still get some wood.
Yeah.
And that way we can.
I'm dumb. I was out at the Osh yesterday or something.
Yeah, let me know if you ever want me to pick something up out there.
Well, we both work out there, so.
That's true.
I gotta take this thing apart and try and see if I can remove the broken gear teeth from the gear train. Because I'm pretty sure I just grenaded one of the. Okay, I need a real drill. I'm pretty confident I just grenaded one of the little planetaries. The planets in the gear train. Let's do a hot adapter on adapter action, because that's long.
Why do you have this extension cord?
Because I unplugged all the plugs over there and I needed another plug and it was already plugged in for outside. In other words, no real reason. Okay. Oh wow! That's a socket cap screw. I can't just... Whoa!
What?
Look at that screw.
You mind if I close this?
Yeah, sure. That screw, I mean, it's as fretted. I think it must have gone through. Oh yeah, look.
What?
You can see the edge of the screw with all the threads. This screw held the key in.
No, I know.
But like, I thought it was a set screw that just pushed the key against the shaft.
Oh, yeah.
But yeah, that was holding the keyway in. Mm-hmm. So it just wore right into the key.
Yeah, through the key, through the bolt.
It's not really visible. Yeah, so I guess now the real question is, okay, so...
Can we knock
what
that?
the fuck is... Yeah, you're right, it's a metal interior section with plastic on it. I think this must have been some sort of linear guide thing. It has to have been like it must have been intended to be like a low friction type thing, and it just wore to the point where it just self-annihilated.
So look at the way this one's constructed. It looks like there's a...
Yeah, but that one's not supposed to move.
Well, right, but it looks like there's a shim that was...
It would be, the most illustrative one to look at would be this one, because that's the other moving one.
Well, okay, right, that's true.
Where did my hammer go?
So maybe that's easy to be plastic.
Yeah, my assumption would be that the plastic is part of the...
Is this for the bearing?
Yeah, that goes on the bottom half. That's the thing the spring pushes against.
Oh, sorry, okay. So I'm going to put that with the spring.
Okay. Okay, that's metal. Alright, there's the... Oh my god. So there's the portion of the keyway.
Yeah, this is a solid metal key.
Yeah, well why the hell is... What's the deal with... Also, wow.
Yeah, definitely wow. Wow for starters. I mean, it's probably... I just can't imagine what's going on.
Yeah, that's definitely plastic and it's definitely moving.
Yeah, it's almost like they wanted it to have play.
Yeah, well, it needs to move.
It needs to absorb.
Let's see, here's my very...
Yeah, so So is it that the key slides in the keyway, yeah?
Yeah.
Okay. That means that at some speeds it's worse than others.
I guess.
The gap is bigger at one point along the shaft.
Well, oops, that's not quite straight on. There we go.
Yeah, I think at very least replacing this key is going to get us at least sort of back to slightly better operating mode.
There we go.
But all of these are constructed with
they've got like a
it's got a sleeve inside. It's got a bushing that this doesn't have. In other words,
no, it had it. It's just
had it. In other words, that's not a shim. That's a worn out bushing.
that's what's left of the bushing. Yeah. Because I guess they're like, hey, that's a wear object. You know, the bushing's probably soft steel so that it wears away.
Yeah.
And this is just completely incorrigible.
So not round is just due to the...
Well, it wore past the entire wear surface and then ruined everything else.
I see.
Yeah. Feels kind of like plastic.
I feel like we could turn the inside and...
This is...
and then put a new bushing in.
Yeah.
Okay.
I think this is plastic. Here.
It looks like plastic.
Yeah. I think these are, well, what I want to do is I want to just look on eBay or, or Amazon and see if we can buy that. I bet we can buy that for $100.
Yeah. Well, it'd certainly be cheaper than trying to machine it.
Well,
no, I agree.
That's not true if we can use the lathe at work.
Can we do a decent job with the lathe at work?
Are you kidding? Paul's lathe is great.
Yeah, that's true. He's got a really nice lathe.
Or even if we could...
So we'd grab it on the outer?
I'm not sure. My assumption
Let's
is...
bring it to Paul. Let's
Yeah.
see if he doesn't just want to, do it for us.
Yeah.
Because I almost feel like he would.
Wow, look at the two edges of this keyway.
Mm-hmm. That's outrageous.
It's not straight anymore. Yeah, so the real problem here is just that once you put a sleeve in here, you have to then cut the key into it.
Mm-hmm.
So
you have to cut the key in the sleeve, but the sleeve can be... you want the sleeve to be the same.
yeah, so the problem is...
if the groove in the key, or if the slot in the... if the slot in the sleeve is wider than the key, then it's not engaging the key, but it doesn't engage.
Yeah, but then the problem is then the key can easily move. Because the problem, the sleeve can move.
The sleeve can move. Is that a problem?
Mm-hmm.
Okay, so you want the sleeve to not...
Well, otherwise it'll fret.
Yeah, I guess that's true.
I'm just distracted by why they didn't feel the need to... I think this key is plastic too.
Which one? This one?
Yeah.
No, look at it. It's not plastic.
I think it's just got grease on it.
Well, I scraped the grease off and it looks pretty metal to me.
Yeah, but the other one looks pretty metal too. I mean, the sleeve is plastic too.
Maybe you're right. Yeah, okay.
Now, where did my X-Acto knife go?
I think it's right.
Oh, here, I'll just use my... Yeah, that's plastic.
Okay. The whole thing is plastic.
No, it's got a metal block in the center. So this is like a bearing key. See, look how this one worked, where it was, my assumption is this was completely encapsulated in plastic with a metal stub in the middle.
I see.
You know?
Yeah, that makes sense. Right, that explains why the plastic goes up.
Yeah, see?
So weird.
Yeah, see, because that looks like metal too. It's all dark and gray colored.
Yeah.
It's probably like UHMPW or something. Yeah, that's kind of annoying. Yeah, let me look on McMaster. I bet they sell shit like this, and if we can find something like this, that'll be informative.
Yeah, I'm just curious. Well, I guess it's pretty clear how it's supposed to be, how it's supposed to work. I'm just curious what happened that caused this.
Yeah.
This wear.
Well, my assumption would be that Joe Billy Bob or whoever it was who did the repair on this that involved putting the inside snap ring on the outside.
Yeah, right. That's a clear.
You know, so we've had somebody who's
yes,
not too knowledgeable about what they're doing in there.
Right.
You know, so my assumption would be at this point that I think they probably put it together and they missed one particular, you know, some safety component or something. You know, like maybe I bet they pulled out part of the sleeve or something, or they just didn't grease it would actually be more accurate, I bet. Like, I bet you need a little bit of, I don't know what you do to lubricate that, but, you know, how would it have worn so badly? It must have been making horrible noises.
Yeah, right?
You know.
Yeah, I mean, if it's literally slamming into this surface.
You know, they must have been using like a horrible, like an end mill or something. Like, not an end mill, a fly cutter or something that was just shocking the shit out of the whole drive chain, you know, once per revolution.
Well, I mean, maybe it's just a natural, you know, failure mode, but damn, it just seems so...
It's so exaggerated.
It's so bad, right?
Yeah. It's like so amazingly horrible. We should call Other Paul and ask for money back.
So we found this.
He didn't know. He never even fired them up.
No, I know.
I don't blame him. I'm just kidding.
No, I know. I mean,
I think we should call him and ask for money back and then tell him we're joking. Because there's a possibility he'll just do it without...
oh my god.
I'm just being an ass.
No, I mean, I don't think it's out of the question to like go back to him, but it was, yeah, I mean, he'll just laugh.
Yeah, I don't even think I'd go with you to the effort.
No.
I don't think I think we bought this working as far as you know.
Oh yeah, I mean, we definitely.
We basically bought it in the works as far as you know state. You know, I'm just realizing there's a couple access plates into the knee that I've never taken off. I wonder what's in there. Where? I wonder what's in here.
Oh.
This one appears to have been... They used a bunch of these like nail-in rivets that are kind of annoying. I actually...
They did not intend for you to get in there.
Well, they used those to hold on the little obnoxious label thing that disintegrated on the column. The sticker that was right there. And I just knocked them out with a chisel.
What are these holes?
That's where they went.
They're not threaded or anything, right? They're just...
they kind of swage, twist in. So they just fit into the metal and you just hammer them in and they're not really supposed to come out except this one's failing. Yeah. I'll probably pull them out, maybe put screws in.
Cool.
Yeah, so...
Massive power cable.
I know, isn't it great? That's pneumatics.
A little longer than it needs to be.
No, that's pneumatics.
Oh shit, okay. Like, looks like the power cord. Okay, good.
Yeah,
That's a relief. I'm glad we don't have an extra 6 feet of power cord.
No, are you kidding? You know how much that cord costs? That's like $20 worth of power cord right there.
Yeah, dude, that's crazy.
Yeah, so the only thing that really bothers me at this point is this. I want to clean these switches. Maybe make them, I just want to, it's just, yeah.
What?
It's gross. And I was worried about
the whole
yeah.
schmutz
It's
down
just,
there.
it's all full of, like all it's, yeah. It's funny how I'm like all OCD about it now.
Funny. Yeah.
Well, I'm such a slob, man.
No, I'm actually surprised by your desire to clean everything on this machine.
I want it to be pretty.
Yeah. Well, let's get it functional. Let's get the main stuff.
I can make it pretty while we're waiting on parts.
Yeah, that's true.
Yeah, that's
I'm thinking we get a new key and we drop it in, right?
well, we need a new key and a new that thing.
Well, yeah, no, that's true. We need a new keys, I guess.
Well, we need a new sheave half.
Well, half yeah.
Because the bottom half is fine.
The
Or the top half.
top half is fine, right?
Yeah, it's just this thing is totally ruined.
Well, what about trying to turn it?
What?
Would you be
Well, yeah, but then what are we putting in it?
we turn it to a specified ID.
Yeah, but then
and
you're gonna have to broach a keyway into the sleeve. And where are you gonna get the sleeve?
Seems like a easy enough piece.
Well,
to
sure, you can get a tube, but how do you broach it?
in a mill.
Okay, which mill? The one that doesn't work until we get the sleeve working?
Paul's mill.
That's not a mill. That's a Paul's
mill.
It's terrifying. It
No, he
scares
got a new one.
What?
Remember, he got a new one.
Oh yeah, I forgot about that. That's not Paul's though.
Oh, it's not Paul's.
No,
Oh, man.
it's one of the Angstrom people's.
I can't believe they got it and Paul let them put it in there.
My assumption on the reason that Paul was okay with it is that Paul's going to use it.
To use it, yeah, but still.
You know. Yeah.
Paul's so possessive over his shop space.
Well, I think you have to realize is that the dude, one of the dudes from Angstrom, I think he genuinely respects that guy's opinion on machining part and stuff.
Paul respects that guy's
Yeah.
opinion?
Because he apparently literally grew up in a machine shop.
Oh, which guy is that?
The other dude who smokes, kind of Asian looking, got a
yeah.
buzz cut.
Cool, okay.
Yeah, so apparently he grew up in a machine shop.
Well, that's awesome.
So I think Paul, he's one of the few people Paul has any sort of respect for in terms of his opinion on machining. Because I'm pretty sure Paul actually asked him machining, asked for his thoughts on machining coming up there.
Oh, cool, that's crazy.
Yeah, Paul doesn't not respect people, he just has an exceptionally high, his standard is kind of physically impossible most of the time.
You're OCD about getting gunk out of the corners of the machine. I'm OCD about getting the little shreds of garbage off the floor.
Well, together we shall make glorious machine music. I like how my hat and the beard ruins the face detection for the camera. It has zero problems detecting your face. It doesn't believe I have a face.
That's not a face. That's hair.
No, wait, now I noticed. Yeah.
That's awesome.
Remember when there was this big scandal for a while because Google's image detection algorithm was identifying black people as gorillas?
Oh my god.
Because they trained a neural net on it, and the neural net was kind of fuzzy. And I guess it went heavily on what's their shade.
That's very disappointing.
I understand how it happened. It was kind of still, really?
Yeah, it's a little on the disappointing side. It's like, this system was designed by white people.
Well, it also means that this system has never been used by anyone who wasn't also white.
Yeah. It's definitely got white written all over it.
Yeah. Well, wow, it's nicer in here now. Yeah, I gotta.
Yeah, I mean, if that bin goes, pretty much everything else can stay, right?
Yeah. And then we'll just, actually, we need to get the saw.
Oh, yeah.
Yeah, I know, isn't it just like, I'm like buying this, it's like, how can I reach it? You want to fold up the table? Table goes inside. Are you trying to put that on your pants, man? Are you feeling your pants?
Yeah, I'm totally good. Oh, it's because your thing is.
That's like a Harbor Freight. You gotta hold it like this.
You doing it?
That's fine.
Oh, that's cool.
Yeah, and
Is that good?
yeah, that's good.
Are you ever gonna put the panels back on